Hello, my name is Adrija and I'll be presenting on the topic robot design using VBots, Tinkercad, Multisim, Creo, and Google SketchUp. The contents of this presentation will be the introduction, consisting of a brief summary about what has been done in the softwares, following which we'll be simulating the softwares. In VBots, the robot has been programmed according to the assignment. The robot has two motors for the wheels, two distance sensors, two cameras, and a GPS and a force sensor. In Tinkercad, two ultrasonic sensors, two DC motors, and a force sensor has been used. The additional parts that are not available in Tinkercad, that is the camera and GPS, will be explained later. The mechanical design of the robot has been created in Creo and Google Sketch. And in Multisim, the circuit design for distance and force sensor has been built. Now we will move on to the VBot software. The VBots environment has been created according to the specifications given. The floor area is of 10 into 10 meter. The floor tile size is of zero point 0.5 into zero point 0.5 meter. We have 6 solid boxes. The robot has two distance sensors, a touch sensor, two camera, a GPS, two wheels, and the body. The body height is zero point 0.2 meter and radius is 0.09 meter. Now we'll run our simulation. The robot will move in a square trajectory at first, having sides of 1 meter, and then it will move in an 8 trajectory. Each circle will have a radius of zero point 0.5 meter, so the robot will be covering 4 square tiles for each circle. Here we can also see that the right camera has a greater field of view. This has been done so that it is easy to detect objects closer to the robot. Now the robot will try to locate the red cube and also avoid collision. So we can see that it avoided collision. Now it will try to find the hidden red cube that is here. We can see that it avoided collision with the walls. Here, in the right camera, the object has been detected and the robot will now move towards the red cube. It will stop just before the red cube. So the robot has stopped. Now we will pause our simulation. We will now place the red cube on top of the robot. Now that the cube has been placed on top of the robot, the force sensor will detect the cube and the robot will try to go back to the center by first trying to go around in a circle and find the green colored center and then moving towards it. We will now resume the simulation. Here in the console, we can see that the force sensor has detected an object. So we can see that the camera has detected the green circle and it is now moving towards the circle. Once the robot reaches the center, it will stop automatically. Now we will stop the simulation. Now we will go through the code. Inside the main loop, we have initialized the two motors of the robot, the set position and the velocity. We have also initialized the distance sensors, the two cameras, the GPS, and the force sensor. Inside the while loop, the pre-programmed code is written for the square and the circle path by using time and speed of the motors. After circle and square is completed, the next step is to find the red cube while avoiding collision. That is when next equal to 1. This is the code for collision avoidance if the cube is not close to the robot. The next part is to find the red cube by using camera recognition algorithm and using ID of the colored cube. These are the conditions to go towards the cube once detected by the camera. Once the robot is close to the cube, the motors will stop. After the cube is placed on top of the robot, the force sensor will be greater than zero point 0.1. Then it will move to the next step. That is finding the green circle at the center and going towards it. This search is similar to that of the red cube. The only difference is that once the object is placed on top of the robot will move around in a big circle to locate the green center and then move towards it. The GPS has been used because when the center is too close to the robot, the camera won't be able to detect it. This is our Tinkercad circuit. We have two motors, two ultrasonic sensors, two batteries, a photodiode instead of a camera, and a force sensor. Now let us start the simulation. At first, the motors will go in a square trajectory and then in a circle trajectory, as can be seen in the serial monitor also. Robot is turning right and then moving forward. Now the square has been completed. Now it is moving in the 8 trajectory. Now 8 has been completed. Now let us check the ultrasonic sensors. So if object is closer, then avoiding obstacle. For the camera, if the photodiode detects an object very close to it, then it will show object is detected and brakes will be applied. And for the force sensor, if it is greater than 100, then it means to return to the center. So it can be seen that the robot is returning to the center. In the code, the digital pins for the motor and sensors have been declared. Functions for set velocity of both left and right motors have been created, which will either turn the robot in clockwise or anti-clockwise direction or will apply the brakes. In the void loop, the ultrasonic sensor reads the sound wave travel time in microseconds, which has been converted to distance in centimeter. The force and camera values are being stored. This is the code for the pre-programmed trajectory path, which is exactly the same as the one in VBots, as can be seen. This is for the circular path. After the trajectory path is completed, if the camera value is greater than 800, that means the cube is detected and the motors will stop. If the force sensor value is greater than 100, that means the robot will start returning to the center. And if the distance sensor is less than 100, that means the robot will start avoiding obstacles. This is the code and connection for the camera module, specifically a color detector module. TCS230 module senses color with the help of photodiodes and converts the current to frequency, which can be read by the Arduino. And this is the GPS module, Neo6M, which will calculate the distance from the current to predefined location. Now we have moved to multisim. This is the force sensor using Wheatstone bridge circuit. The resistance change in the Wheatstone bridge due to the force sensor causes a voltage change, which is then amplified by the non-inverting amplifier to give us the full input range of Arduino. For the distance sensor circuit, an LED and photodiode are required. The LED here is made to work at 3.765 kHz using a 555 timer circuit. From the graph, we can check the frequency. Here the time period is 267 microseconds. This is the receiver part of the distance sensor circuit. The photodiode detects the 3.765 kHz frequency from the LED along with other surrounding noise light frequencies. To remove these unwanted noise, the output is then passed through a bandpass filter, which is then passed through a rectifier and a low pass filter to give a DC output. Since the photodetector gives a current output, the current has to be converted to voltage first. The current has been taken as 1 milliamps with a current offset of zero point 0.1 milliamps, which relates to the other unwanted noise frequencies. The frequency is given as 3.765 kilohertz. The output of this IV converter is very low, so it is then amplified with a differential amplifier to get a higher voltage output. We will now run the simulation. So we are getting an output of 2.12 volt after the amplifier, and we can see the same in the oscilloscope. This amplifier output is then passed through a bandpass filter having a center frequency of 3.765 kHz. We can check the bandpass filter graph through the Bode plotter. So we can see that the center frequency is around 3.765 kHz. The output of the bandpass filter is then passed to a rectifier to convert it into a DC output. We can see the output of the bandpass filter and the rectifier in the oscilloscope. So the frequency is coming approximately to 3.765 kHz. The output from the low pass filter is very low, and hence an amplifier has been used to utilize the digitizing range of the Arduino. So we are getting an output voltage of approximately 5 volts after the amplification. Moving on to the mechanical design, this is the main body, this is the camera, the distance sensor, the Arduino, the force sensor, the DC motor, and the wheels. And this is the complete assembly of the body. This assembly drawing has been built in Google Sketch.